There we go. Okay. Homework will be here. I'll also give a short summary of what was done in the lesson. Lesson videos, that's where the lesson videos are going to be posted. There are some study tips, the first of which is to put away your phone. Okay, so if you're not good at putting away your phone, or if I discover that the class has a problem with that, I have a cell hotel. And everybody's name is up here. Okay, you guys are blue, you're at the top, and it's alphabetical by last name. So for example, Leo, you're the first name here, okay? And then down at the bottom we have GM, okay? So if you want to put your phone there, you can. If you're desperate for a charger, I have an Apple charger, I have a USB-C, and I have a micro USB up here, but only one of each, so only if you're desperate. Let's see what else. Upcoming quizzes and tests. We don't have any of those yet, but that's where I will put them. They will also go in homework, but it's kind of nice to be able to go, oh my God, is there something happening? Okay, questions? Should we learn some stuff? Okay, let's learn some stuff. Enough of that nonsense. Let's go here, and we're going to go to here, and we're going to go to 61, 1.4a, page 61. Page 61. So if you have taken physics, this first unit might be a little bit boring for you. If you're bored and you would like to work ahead on something that's a little bit different, let me know. I can accommodate that. Okay? So you are expected to memorize the following table of SI units. Okay, so we have volume, and the symbol for volume is capital V. That is a capital V, not a lowercase v, a capital V. Does anyone know what a lowercase v stands for in science?
Velocity.
Velocity. That's why volume is a capital V. Page 61. Distance is a lowercase d, lowercase. And amount of matter, this is going to be the one that's going to be hard for you to remember for now because it doesn't mean a lot to you, okay? N, the amount of matter. It's actually a way of counting atoms. Do you guys know how small atoms are? They're like so small that you cannot even imagine it. Can you picture a tablespoon? You got a picture of a tablespoon in your head? Okay, you can hold it here. I don't know, how big is a tablespoon? Maybe like that big? Okay. 1 tablespoon of water contains 6.02 times 10 to the 23 water molecules. Now, what the heck is that times 10 to the 23? If you've done physics, you probably know. If you haven't done physics, you might not have heard of it. But it means that we take 6.02 and we multiply it by 10 23 times. So what that number is, it's actually 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That many water molecules in 1 tablespoon. That's how small molecules are. Atoms are even smaller than molecules. Now, what does this have to do with the amount of matter that we were talking about? This number is called 1 mole. And we have a whole unit devoted to the mole in Unit 4. For now, you don't need to memorize this number. For now, you don't need to do much with that number. You just need to know that it exists and that it is called a, what's it called? A mole. And it's a counting unit. You know, when you go and you buy some eggs, you don't normally say, I'm going to the store to buy 12 eggs. What would you say instead? I'm going to the store to buy a dozen eggs. So you wouldn't say, I am going to measure out 6.02 times 10 to the 23 water molecules. You would say, I'm going to measure out 1 mole of water molecules. Okay? And that is how we count the amount of matter, which is signified by the letter N. Is that an uppercase N or a lowercase n? It's a lowercase n. And given that the mole, which is the unit, is 6.02 times 10 to the 23, what do you think N could stand for? Any ideas? Well, what's that? Why is this pen not working? Hello? There you go. What is that thing? That thing is something that starts with an N. What's that? What's that? It's a number. What's that? It's a number. Okay? So, what does this N probably stand for? It stands for a number, and that number is measured in moles. Okay? Now, temperature is capital T, and it has to be capital T, because what is lowercase t? Lowercase t is time. And then finally, mass is lowercase m. There are more quantities and units than this, but these are the 7 that are important in chemistry 11. Okay? And the unit that we use for volume is the liter. What I would like you to do is I would like you to hold up your hands and show me approximately how much 1 liter of milk is. 1 liter. You might need 2 hands to do it. No, like just showing the size of the maybe container of milk. Yeah? So something like this. Yeah, if you think about a liter of milk, it's about like that. If you have 2 liters of milk, it's bigger. And if you have 4 liters of milk, it's like that, right? So that's what a liter is. All right. The unit for distance is the meter. I would like you to show me with your arms approximately how much is a meter. About like that? Ish? Right? Meter. Amount of matter, like I said, that one's going to be hard to visualize because it's such a big number and it's counting such small things. Temperature. Now, Temperature is actually in science measured in Kelvin. What would you normally measure it in, though? Tell your partner, what would you measure it in? You would measure temperature in I heard it from someone over here. Celsius, degrees Celsius. Okay, so we will probably in our lab be using degrees Celsius because that is what our thermometers measure. Okay, do you guys know the symbol for degrees Celsius? You have to put the little 0, that stands for degrees. And then what do you put for Celsius? Capital C. It's not Celsius degrees. It's degrees Celsius. The little 0 goes first. The degrees goes first. And then we have mass. The unit of mass is actually not just a plain old gram. It is a kilogram. These are what we call the SI units. It comes from when they did the standardization of all the units. They were in France, and they decided that they were going to call it the Système International de something or other, okay? I apologize for my terrible French accent. But Système, S, International, international, I, SI units. And they said the standard unit for distance is the meter. The standard unit for amount of matter is the mole. The standard unit for temperature is Kelvin. The standard unit for mass is kilogram. And the standard unit for time is second. And they came up with different ways of defining these. Like a second has something to do with the vibrations of a quartz crystal. But I don't really understand it, so I'm not going to worry about it too much. Or it's cesium. It could be cesium. At any rate, it used to be that they had a big block of iridium, and it weighed exactly 1 kilogram. But the problem was that everything breaks down over time. And so over time, their exact 1 kilogram was getting smaller and smaller. They now have a new definition for a kilogram, but I don't understand it. So I'm not going to teach it to you because I don't expect you to understand it either, okay? All right, now how on earth are you going to remember all of these units? Well, we're going to learn a little song, okay? And we're all going to sing with me. Not at first, I'll start, okay? And we're going to be focusing on the units because that's usually the part that is difficult to remember, okay? And here's how it goes. It goes liters, meters, moles, and Kelvin, kilograms, and seconds, liters, meters, moles, and Kelvin, kilograms, and seconds. I'll do it one more time, and then you're going to join in. Liters, meters, moles, and Kelvin, kilograms, and seconds. Liters, meters, moles, and Kelvin, kilograms, and seconds. Okay, everyone join in now. Liters, meters, moles, and Kelvin, kilograms, and seconds. Liters, meters, moles, and Kelvin, kilograms, and seconds. Liters, meters, moles, and Kelvin, kilograms, and seconds. Liters, meters, moles, and Kelvin, kilograms and seconds. Liters, meters, moles, and Kelvin, kilograms and seconds. Liters, meters, moles, and Kelvin, kilograms and seconds. Whew. Very nice. Give yourself a hand. Okay, now, are these things here that I've written down, are those the quantities? Or are those the units? Those are the units, okay? What I would like you to do is I would like you to tell your partner if you can tell me the quantity that goes with each of those units. So see if you can tell your partner the quantity that goes with each of those units. Yes, yeah.
No, the quantity. Simple. No, look at everything. Very calm. But let's look at W, but not W. Big B. What about meter? Quantity. Come on, man. I thought you looking at your book. D, little D. What about mole? Mole. Talk about the letters supposed to have. What about Kelvin? Oh, really? Big T. What about kilogram? Come on, you gotta know kilogram. Yeah, what's the quantity? The little f. What about a second? You gotta know.
Okay. I'm going to see if I can remember any names, which I won't be able to, pretty much. You know what I'm going to do? I'm just going to point at you and you're going to tell me your name and that'll help me learn it. Does that work okay for you? Are you scared for me to do this? You can always say pass. If you're like, no, I don't like being called on, you can always just be like pass and I'll move on to someone else, okay? So we are looking for the quantity that is being measured if we use the unit liters. And I'm going to ask, I'm going to start at the back there. Your name is? Jerome. Jerome, what is the quantity being measured in liters? That would be volume, yes. And it's Leo? Okay, so I got Jerome and I got Leo. Leo, what is the abbreviation for volume? That's the abbreviation for liters. What's the abbreviation for the actual term volume? That's okay, no worries. The abbreviation for volume is just V. So that's what I mean when I say abbreviation, okay? Part of it's just getting used to the terminology I use. So we have the quantity and we have the abbreviation for the quantity. All right, our next unit is M. And I'm going to ask you, what's your name? Braxton. Braxton. Okay. What is, well, do you know what M stands for actually? Meters. Yes. Meters. Thank you, Braxton. And beside Braxton, we have Anea. Anea, what is meters measuring? What quantity is it measuring? Distance. And what is the symbol? What is the abbreviation for distance? It's a D. Do you know if it's capital or lowercase? It's lowercase, yes, indeed. And your name is? Anthony. Okay, excellent. All right, you got the tricky one. We've got a mole. And this one's kind of weird. What is mole short for? M-O-L is short for? Mole. Yes, mole is short for Mole. Okay, they just took off one letter. I don't know, it's a bit goofy, right? And if we are measuring in moles, what quantity are we measuring? N. Yes, we are measuring N, lowercase n. And your name is? Kian. Good stuff. So we are measuring N. And what does N stand for? Amount of matter. And your name is? Sorry? Jian. Jian? Yeah, okay. Amount of matter. All right, that capital K. I want to say Alicia. Yes? Okay. Alicia, what does capital K stand for? It is temperature, yes. The quantity we're measuring is temperature. And Matthew, if I say K, what is K short for? Short for Kelvin. And you'll just have to excuse my pen. I make a line that's supposed to go like this, and it does whatever the heck this thing is. It just does it. So if you see that, it's not because I can't draw, it's because the pen does that, okay? Anyway, what is the abbreviation for temperature? Is it ARI? Do you remember? T, is that a capital or lowercase? Capital, yeah, good stuff. All right, kg. Marco. That is for mass, yes. kg measures mass, and kg is short for kilograms. And mass is abbreviated M. And finally, our last line, S, the quantity we're measuring is time. And time is abbreviated lowercase t. And S is short for seconds. So if you know your liters, meters, moles, and Kelvin, kilograms and seconds, liters, meters, moles, and Kelvin, kilograms and seconds, you can use that to help you fill in the rest of the table, okay? If you don't want to do them in that order and you don't want to sing the song, I have no problem with that. Learn it however you want to, okay? So those are the SI units. Système International, they are the standard units of science. Huzzah. Now, to be honest with you, the liter actually is not the standard unit of science. The unit of volume, the official unit of volume, is a meter cubed. Now, how practical is a meter cubed? Anyone want to go measure things in meters cubed? Probably not. Yes? Because it's just a really big volume. So in chemistry, even though the liter is not the official measurement, we're going to use liters instead of meters cubed. All right. You are also going to memorize the following prefixes. Take a look at them and see if you already know some of them. Hopefully you know centi, yes, and milli, and maybe kilo. But the key thing here is that we are moving from the biggest to the smallest. And to be honest with you, in this unit, you aren't actually going to need to know what each prefix stands for. We're going to leave that for unit 2, but you're going to learn what they are, what the prefixes are, and what their abbreviations are. Okay? So we have mega, which is big, kilo, and I'm just going to put these up at the top, but you're not required to know this yet. This will be for next unit. Mega is 10 to the 6. Kilo is 10 to the 3. The blank is just there because if you have a megagram and a kilogram, the next size smaller is just a plain old gram. Okay, so that means there's no prefix there. And then we have deci, which is 10 to the negative 1. Centi, 10 to the negative 2. Milli, 10 to the negative 3. Micro, 10 to the negative 6. And nano is 10 to the negative 9. So for this quiz, for this test, you will be expected, like the Unit 1 test, which will come up in, I don't know, 2 weeks or so, something like that. I'll give you at least a week's notice before any test, okay? You'll be expected to be able to list these from biggest to smallest or from smallest to biggest. But I will always ask you from biggest to smallest because guess what I have to help you remember this? I have a song, and guess what? You already know the tune because it is the same tune. Okay, so we're gonna go through this. We have mega, kilo, deci, centi, milli, micro, nano. Mega, kilo, deci, centi, milli, micro, nano. And if you're not actually singing along, you should at least mouth along the words and sing it in your head. If you're too shy to actually sing along, because it will help it stick in your brain. All right, let's do it a couple more times. Mega, kilo, deci, centi, milli, micro, nano. Mega, kilo, deci, centi, milli, micro, nano. Mega, kilo, deci, centi, milli, micro, nano. Whoops, that micro went weird. Mega, kilo, deci, centi, milli, micro, nano. All right. So you would be expected to know that mega is capital M. Kilo is small k. All of them are small except for mega, which is the biggest anyway. Okay. And then there's this weird one down here. What the heck is that thing? Anyone know what that is? That is the Greek letter. And in fact, maybe I'll do it over here. This is the Greek letter. Oh, I've written it here. Aren't I clever? Look at that. It is the Greek letter mu, pronounced mu, like a little cat, okay? Now, many people have troubles writing the letter mu. Some people write it like a U. Is that correct? No. What you're going to do is you're going to draw a line. So draw yourself a line, just kind of underneath. And you're going to start down below the line. So start here. And you're going to swing up. Okay, so we go up first. And then we go down up. And then we go little tail at the end. So up, down, up, down. Up, down, up, down. And the tail at the front is bigger than the tail at the end. And if anyone is actually Greek and I'm mangling your language, I really apologize. Okay? And what does that Greek letter mu stand for? Which prefix does it stand for? Tell your partner. That prefix stands for one of the M's. Micro. Excellent. Okay, good stuff. All right. Density is on our next page. Density is a derived unit. A derived unit is where we take two or more SI units and we combine them. Did you guys know that density is mass over volume? Yeah? Hopefully, you've been learning it since grade 8. I think they start teaching it and you kind of get used to it over the years. Now, that's what the formula is. So what could the unit be? What's a unit of mass? Tell your partner, what is a unit for mass? What is mass measured in? Mass is measured in kilograms, or we could say also grams or milligrams or megagrams or micrograms, but some sort of gram, yes? And what is volume measured in? Tell your partner, what is volume measured in? Volume is measured in liters or milliliters or kiloliters or whatever you like. Okay, so it could be grams per liter. The reason it is a derived unit is we have two or more units combined. And that makes it a derived unit. I think they should have just called it a combined unit, but that would be too easy. Now, once you finish writing that down, I would like you to think if you can think of the formula for the volume of a rectangle. If you can, tell your partner, what is the formula for the volume of a rectangle? Volume is what does L stand for? Length. And you'll notice that I have a tendency to make my L's sort of like cursive L's because otherwise they look like ones. Okay, you don't have to do that though. That's length. And then we're going to take length and we're going to multiply by the width. And then we're going to multiply by the, what do we call that one? That's our height. And if we take length times width times height, we get the volume. So here's a little example of what we might do with that volume formula, length times width times height. A decimeter is equal to 10 to the negative 1 meters. Do you guys know what 10 to the negative 1 means in terms of a fraction? Yes. It's 1 over 10 to the 1, which is just 1 over 10. And how would we say that? We would say that that is 1/10 of a meter. So what I would like you to do is I would like you to think this is a meter. I would like you to show me either with both hands or just one hand. How big is 1/10 of a meter? How big is 1/10 of a meter? Show your partner. Okay, and I'm going to go on here and I'm actually going to put my thumb right at the 10 centimeter mark. So over on this side here, over on your left, my right, over on this side here, that is 1/10 of a meter. So that is a decimeter. That is a tenth of a meter, a dm, a decimeter, just over here. So just about that long is a decimeter. Okay. Now, if you take a decimeter, if you have a cube and it's 1 decimeter by, 1 decimeter by 1 decimeter, we get 1 decimeter times 1 decimeter times 1 decimeter. And what is 1 times 1 times 1? This is super hard. Hardest question of the year. 1 times 1 times 1 is 1. That was sad. Everybody, what's 1 times 1 times 1?
1.
1. Yay. Okay. Now, 1 times 1 times 1 is 1. What is decimeter times decimeter times decimeter? That is a decimeter cubed. There's no other way of doing it. That's just a decimeter cubed. And do you know what we have done? We have combined units. So what have we gotten ourselves? We have gotten ourselves decimeters cubed, which is a derived unit. So when we say derived unit, what we really mean is a combined unit. Okay, so we have a table of some derived units here, but what does it say beside this table? It says you are not responsible for memorizing this table, okay? Don't need to do it. They're just here to show you some other derived units. So for example, do you remember our liter? A liter is actually a decimeter cubed. A decimeter cubed is a liter. So a liter is actually a derived unit. Have you guys learned about energy? Did you learn about energy in grade 10 and 9? Yeah? Energy is measured in what unit? Joules. Joules. And look at this crazy unit here. It is a kilogram times a meter squared divided by seconds squared. Isn't it nice that you can just write J for joules instead of kilogram meter squared per second squared? Right? Pascals is a measure of unit of pressure. That is a kilogram over meters times seconds squared. Oh my gosh. So that's a lot of things. All right? Now your homework, which we'll let you start on now, Homework has an M-E in it. It's not just, anyway, homework is going to be pages 62 to 63. Okay. And also, pages 35 through 37. And let me just check on one more thing. Do I want to do that? No, I'm going to do that next day, but I am going to assign you pages 41, 42. Okay, because it's another little video, but it's a really short one. Okay, so 62 to 63, 35 to 37, 41, 42. No, 62 to 63. Oh, and just so you guys know, when you're looking at, let's say, page 35, there's a QR code at the top there. What will that let you do? It's going to let you go and see the video. Okay, so there's a video for you to watch now. You can also type in the URL if you want to, if you're on your computer at home, or you can just search for Tyler DeWitt Accuracy and Precision. And this tells you that it is 9 minutes and 28 seconds long. And there's going to be things for you to fill in as you go through. And then when you get partway through, you're going to be like, oh my gosh, there's another video, which is another 9 minutes and 45 seconds long. Okay? And you're going to fill those in as you go along, and then you're done. Okay? And then finally, solutions video. This one's only 2 minutes long. Okay, so that's a 2-minute video. But what should you be doing as you do that video? You should be filling in the blanks. So you can watch these things at slower speed or faster speed, or put on the captions. Okay? I mean, is this allowed? Okay, I was close. A lot of this where I carry water. No, I didn't. Oh my God. Ah! Yeah, okay. I'm like, 'cause I know the last piece, but I don't want to. Hi. And B. Yeah. And B. Well, it's part of it's written out, since the whole lesson. Often before I come to class, I'll try and look things up and working with the whole pronunciation guide, but this. Well, they're just gonna work on this. So I'm like, I'm not prepared for this. Fun and B, excellent. Adam. Excellent. Okay.
These are all.
They're all the same. Oh, folks, when you get to the tables that are all the same, maybe don't do them all on one day. Maybe do like one today, one tomorrow, one next day. Yeah. Yeah. 41, 45. But we're done in 5 minutes.
Yeah.
Yeah.
I don't follow you.
Okay. It's been a while. No. Bottom that.
This is
Lauren. Okay, Lauren. Megan. Lauren. Megan. Oh, I got a question. Yeah. Ah, okay. So, yeah. So that's, yeah, does that make sense? So when you have 2 letters like that, this one is prefix and the second start with the same thing for this one. Yeah. That's just what it is. Yeah, we're focusing on that. Exactly. Yes. There's something that how big are we? Volume. You stare. Scott, I talked to you before. They're not. Wow. And I know Will, and you are. There. And it's J. Ron, not you. Okay. I'm wrong.